All right, next, let's take a look at problem 3. So the natural frequencies of a beam are directly related to the roots of the frequency equation. For a beam fixed at both of its ends, the frequency equation is this. Find the first 5 positive roots of this frequency equation. Okay, we're asked to write a script just like the last one, and we're told to consider the range zeros less than x is less than 20. And the note is this doesn't include the root at x equals 0. Okay, cool. Other note is if you generate a plot and find it difficult to see the roots, consider changing the y-axis limits using the function ylim. I tried -1 to 1 to -20 to 20, all of which work well. Okay, so let's see what we have, or let's see what we have. All right, so I'm coming back over here. Let me close off problem 2. I need to start with an air function. So actually, let me do a clear all in CLC, just to make sure we're starting on a fresh page. So this is going to be function res, and I'll call this air prob 3. So my air function has a single input, and a single output. Great. And so now I'll compute my air. And so my air function, all right, so fzero is going to iterate on values of x until it finds the value of x such that my expression evaluates to 0, right? It's looking for varying the value of x until my air function returns a value of 0 corresponding to my solution. So I need to rearrange this equation. So rather than looking for when this is equal to 1, I want to look for when this minus 1 is equal to 0. So I'm looking for res is going to be equal to cos x times cosh x minus 1. Okay, and I'm going to put a period in here, just making sure everything's element-wise. Okay, so there's my air function. Okay, and I could create a new function on top, but I'm going to do the new script route because I'm assuming that's what most of you would probably do. I'm going to call this problem 3. Okay. Okay. And to visualize, okay, I'm going to start by plotting, and we're told to search over the range of 0 to 20. Okay, so this could be an F plot, air prob 3. And that's going to be from the range 0 to 20. Okay, so let's do that. Oh, not enough input. Oh, I forgot function handle, my @ sign. So run. Okay. Man, this looks crazy. How am I supposed to see any roots from here? Okay. So that's where my hopefully the hint correct came in is 1. Consider this range. Okay. Then if you find it difficult to see, let's look at, so I said, oh, I've tried a, y range from -1 to 1 and -20 to 20. Both seem to work well. All right, and so I'm going to set my y-lim. My y-axis limit, and I'll do -1 to 1. Okay, and when I do that, right, I don't see much in terms of the graph, but I see my stripes. So I say ignore 0, like don't take 0 as a root. But then here's 1, 2, 3, 4, 5 roots. Okay, and if I want to make it clear, right, in terms of where those are, okay, I'm actually going to cheat. I'm going to come back over to problem 2. Okay, and I'm going to copy this. Okay, and so this though is going to go from 0 to 20. Okay, so I'm going to plot horizontal line, so 0, 0 to 20, 0. So now when I run, I have my horizontal line, and it looks like I have a root here, 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 and here. Okay, cool. Okay, so I wish I'm gonna shoot, that didn't quite behave like I want to. I try and I want to try and make it so I can see my plot at the same time to make it a little easier on me here. Okay, cool. So as I set it up, Okay, let's get each. So now I'm going to solve for my 5 roots. Okay, that's what we're asked to do, right? Solve for the first 5 positive roots. And so I'll call it like root 1 is going to be fzero at air prob 3. And then I give it a range, or even in this case, initial guess should probably be fine. Right, because here it's looks like it's going to happen about 0.47, or yeah, 4.7. Let me just copy and paste my second root. Okay, bracket would be preferred, but this is fine here since the ranges are going to be so small. 7.8. Okay, third. Come on. It doesn't seem to want to let me off that 1 point. Okay, I'm not sure what's going on, but I can guesstimate from here. This next one I'll put at like 11. Okay, then this one's at about 14. And this one is about 17, we'll just call it. Okay, so if I close that, and I run, 4.73, all increasing in value, looks good. So there's my first 5 roots. And if I had time, right, I could even plot all of those right on my figure to confirm. Okay, but that's problem 3.